Hello everyone. Today we will start lesson number 2 of example number 2 by moving data from the camera coming in pixel data in streaming way through a line buffer to our output. So let's start. So if you remember, we have declared line buffer as a way where we can momentarily store data one by one in this, not a very big area, just for example, one line of data, 521. So in this way, we'll store pixel coming in data stream one by one. Then we can shift it to another cell and so on. The last one where we can output this pixel, for example, number 1. And here we have number 3, 2, 3 until 512. This will be the same 1, 2 until the last one where we can install it, as I told you last time, in ROM or PDA, another PC, or to all these three, but through an ARM processor in software way. Okay, let's start coding now. So we open Vivado LS, then we declare line buffer, same thing as we are used to do. So we can call it, for example, image line. Okay. We are having this line buffer declared. We are going to do the coding, and we try to test it whether manually or we will write a test bench for testing the line buffer, because it is the most important component in our design. So first, of course, we need to declare the input clock, input, of course, the input data. It will be one by one in our case, from 7 to 0. Also, we need to check if this data is truly coming from the camera and if it is valid or not by using this input register. The output, of course, we need to output the same amount of data. Of course, in future applications, we'll output more than 1 byte. So we call it data. And we need to add another input to command it to write or read. It depends on the speed of the input data. So that's why we need to put this input. So this is the initial output, this initial declaration. Thing to declare the line of bytes from 0. In this case, for example, we can say for one line from 411 to 0. Also, we need to declare writing pointer. Why? Because log of 521 will give us 9 bits. So we need from 8 to 0 bits to go through the line buffer from cell number 0 to cell number 511. Same thing, we need another counter or pointer for the reading operation, because we are writing pixel by pixel. When we finish or detect we have finished, we need to read it again. We need to declare or to start by process, always positive edge of the clock, what we'll be doing, begin, and we should be in line buffer. So using this writing pointer, we should be storing the input data. Here we have to add another condition, whether the data is valid or not. So a data valid is valid, we put it inside the line buffer. This is the first process. Second process is also on the positive edge of the clock. Begin and end. In this one, we need to increase or increment the pointer. Writing pointer will receive pointer plus 1. Of course, in this case, we need to do reset. If reset, so the right-hand pointer will receive 0. If we are not in the reset, this means we are reading or writing in the buffer from the camera one by one. Maybe you can okay, it's okay. Now we need the same thing but for process. Always positive edge iClock and if we reset this pointer will be incremented plus 1 of course, and this we will initialize our pointer. Okay. Now we have a mistake PNTR. Okay, we don't need this, and we need output the data. Our data is concurrent with equals line of this pointer. Control V, and that's it. Okay. We forgot this one. We need to enable the reading. When this is enabled, it means we need to add something here. If reading where we start implementing the pointer. This is the code of the pointer, so we need first when the data is valid. When we finish writing, oh, there's a mistake here. Oh, data line buffer. So the mistake here, assign and remove this one. This is some of Verilog, okay? It should be now. It is okay. If we summarize, we need first to write in the line buffer the data coming, the valid data which is coming from outside world, we put it in the line buffer. In the same time, we need forget something here. Also, we need to check if the data is valid. Otherwise, we cannot increment the writing process if the data is valid. So, if the data is valid, we increment this. The buffer is getting the data by pixel or 8-bit by 8-bit. When we finish this, we wait for the reading, increment this, which will come straight away to the output data. Following step is to simulate this. So it is top level. We don't need to set it as top level. We just run simulation and see what does it give. All right. Now we start simulating. First, we need to set, as usual, 100 nanosecond. Second, for reset, set to 1, and initialization for data, data 0, valid 0 as initialization. Then the output we don't need. Read data as an input, we say we should put it or set it to 0. We should run few cycles. Then we start by removing the reset and inputting data cycle by cycle. For example, we start from 1. We don't need to forget the data valid, otherwise it will not be taken into account. So first one, you see that the valid is 1 and the data is 1, and this counter started counting. Following data, run just for one cycle. You see that writing pointer is incrementing. Same thing, we will put just few data for demonstration, but in practice this will be 512 pixels for one line. Okay, 2, 4, you can see that has incremented from 0 to 3. Last one, of course we can go on until 511. Now we should start reading if it's working okay. So we set this to 1 and see if the data is outputting something. Here is initial value, we'll see. So this is 1, and output data is given some data. Of course, you will see the reading pointer incrementing, but at the same time the writing is incrementing. This is a mistake because we have set or let the idata valid as 1. We should set it to 0 to this pointer incrementing. So it will take one cycle to take effect, and we'll see this has stopped incrementing, but this is still incrementing. So since we just put up to 5, for example, we add another value, for example, AE in hexadecimal, we set the value to 1, but we should remove reading because it's not good to read and write at the same time in this example. Okay, AI. Now we should read and see if it is reading this value or not. Okay, output, where is output? Still 5, we need another cycle. Okay, this is the data that we have just input, and this is still incrementing because we forgot to put this again to 0. In practice, when it is automatic, we shouldn't be doing this mistake. We'll check the line buffer. What have we done? Because it's 512 line, so we need 512 pixels to fill the whole line buffer. But if you check for the first ones, you can see that we are doing what we had to do. For line buffer 0, 1, 2, 3, 4, 5, so on until we reach the last one, and this is what's required from us. Now we'll try to do this testing automatically by setting a test bench.